Good afternoon, and thank you everyone for staying to the very end. I'm Tom Reddick, and I'm the moderator to the moderator. We're really happy that Joyce Cacho could come to our meeting today. She was a late addition to our program. She's the new sustainability officer for a very large veterinary and animal additive, feed additive business in St. Louis, Novus International. She handles global corporate social responsibility for that company. She has a prior she was the corporate counsel on Africa. She also has worked with Rabobank International, and she will be the person introducing our speakers today. Thank you, Joyce.
Thank you very much, Tom, and thank you all again for hanging into the very end. As I'll take the opportunity to make a few remarks about animal agriculture, globalization, because I see it featuring quite a bit in the slides that have been shown here, certainly in the time that I've been with you. I really do believe that two things. That we're at a crossroads, and so the U.S., non-U.S. dichotomy is something that needs to be ironed out at the same time that the U.S. is working out what it will be doing in response to climate change. And the other thing is that the thinking around agriculture has to be one of that we are in many ways looking to quantify and remunerate in some way what farmers have done historically and globally, which is being stewards of natural resources. I hope that's not revolutionary terms talking in this room, but certainly that's very important. A little bit about Novus International. Novus International is a livestock feed ingredient company, so no, you're not going to see our brand on products that you buy, but we're very much involved with the producer and the consumer side of what goes on in the food industry. So we actually have boots on the ground in 50 countries. We sell into 90 countries. And frankly, this is, I think, Novus establishing the role of sustainability officer, chief sustainability officer, speaks to the fact that we would like to be a company out in front of this issue, helping to shape the dialogue. So without further ado, I think what I'll do is introduce our three speakers in the order in which they're going to be speaking so that we can get to the substance of the matter and have a little bit of time for discussion at the end. Our first speaker today is David Mladenov. Mladenov? Very good. The Bears Bascom Professor of Conservation, Department of Forest and Wildlife Ecology, manages Forest Landscape Ecology Lab, and is the originator of the Landis Forest Model. David has a PhD from University of Wisconsin at Madison. Our second speaker will be Jane Early, who's a partner in Early and White Consulting, formerly of the World Wildlife Fund, and the U.S. Trade Representative's Office. She holds a law degree from the University of Maine. In closing us out, we'll return to, in greater detail and terrific perspective, to Rick Krause, who is a Senior Director for Congressional Relations with the American Farm Bureau Federation. It's a wide range of environmental issues, including, he handles a wide range of environmental issues, including climate change and international water. Rick holds a JD from the University of Michigan. With that, David?
Okay, thank you, Joyce. Thank you again, all of you, for sticking it out here today. Well, this version is different than mine. Huh?
Yes.
This one?
Bottom and to the right, you'll find the right.
This one?
The mic. bottom and to the right.
Oh, that's what I'm looking for. Okay. Well, I'm going to switch gears a little bit here. In some sense, back to science, which we pretty much weren't focused on for seems like hours and hours ago. I guess it was the first session this morning. But I'm going to do it in a little different way. I'm going to be talking about forests specifically, and I'm going to do it through a case study, which I hope we'll see not only has specific relevance for where it was done, but also in a somewhat broader realm as well. I want to acknowledge that most of the work I'm talking about is from a paper that we published in the Proceedings of the National Academy this spring. And the first author on the paper, my colleague Janine Rumtala, is now at McGill. And we did this kind of part of the end of her PhD with me and some additional work as well. And Murray Clayton was our statistician. So the motivation for this research, which I think is a little bit unusual, is to use historical data to try to validate models and look at biological potential for sequestration. And we want to know, well, what is the potential in existing forests and former forests, using the state of Wisconsin as a case study. And we also just wanted to explore the value of historical data for kind of approaching this question or a problem from another direction, which we've typically done for a long time by trying to extrapolate from field studies or model simulations, for example. And so one question, at least from more of a strictly ecological viewpoint of our interest, is do forests continue to sequester carbon for a really long time? And for a number of decades, really, we thought not. We thought that it really kind of topped out after some time. And then in hindsight, that's maybe nested within more of a commercial forestry view and where the maximum productivity of forests is. But that's somewhat of a different question. And growing evidence suggests that the answer to this question is yes, that forests continue to be carbon sinks for quite a bit longer than we thought, and contrary to past studies. And it's in contrary both to what we thought we knew just in general, as I just said, but also some work that came out in the last 20 years or so, especially in eastern North America, suggested that, forests in eastern North America have regrown and they've sequestered quite a bit of carbon, but that's probably going to taper off now. They're probably about topped out. And so we're trying to, underneath this is really the question, is this biological or is this how we manage forests and what we do? Because that entails then a bunch of social choices. So the graph that you see here is from a paper about a year and a half ago that was in Nature, and this was the study that looked at forests from all over the world. And what's important here is that you see forest biomass plotted against age. And the main point is that there's a very dramatic continuing increase with age of forest and growing biomass. Another issue that brought this question up in my mind, because actually for the last decade we've been interesting both working with simulation projection models and using a lot of historical data. And in looking at historical data in Wisconsin was just the phenomenal amount of lumber that was extracted in a very short period of time, and even estimating maybe 30% or 40% beyond this as waste. And the amount of time that this occurred means that there was no regrowth. So this was one big slug that was out there. And if you start to look at the numbers, it suggests, maybe there was more in this forest than we originally thought. So other motivations for this research are a couple of things more specific to our meeting here, and that is to contribute to this discussion of carbon sequestration, but also something that I was kind of surprised that we heard so little about today until actually maybe the last question before this session is, and that is, what about carbon sequestration values of forest in relation to intensive biomass energy harvesting? Because this is sort of like the elephant in the room, and this is what's happening in the upper Midwest where I'm from. So how should forests be used and managed? And I think this is important to look at these two things because of where incentives are right now. I mean, maybe they will change in the future. But where they are right now, we're making a lot of decisions, I feel like important policy decisions, without really having all of the information on the table. And to me, this is about bioenergy and biomass harvesting of forests. I think that in relation to this issue, if I don't digress too much, I think a lot of things being proposed now will prove to be economically and ecologically bad ideas. But nevertheless, society may decide to do them because that's what we do. We make trade-offs. But when we make those decisions, we want to make sure that we have all the information on the table to weigh. And that's what concerns me is I feel like we don't right now. So we need to be able to assess those trade-offs better. The other thing that I think is relevant, and some of this has come up, and that I think there are some myths and misunderstanding, carbon accounting artifacts, what is really carbon neutral. Again, this relates to the bioenergy issue. I hope I'm not leaving the main focus too much. And whether old versus young forests sequester the most carbon or most valuable, ideas of emissions accounting and what is net substitution, things like that. These are really big issues for us as we try to promote the value of forests. So from strictly a forest concern, well, obviously the issues of loss and degradation we've heard about. There's also ecological simplification, and we mean that ecologically in terms of the forest structure, its composition, which is the species that are present, and the function, how everything works together. And this is really important because unlike agricultural systems, which are really much, much simplified, forests are a natural system to varying degrees. And we're making, again, these decisions of carbon versus bioenergy by what I call a seduction of the spreadsheet, where we're looking maybe only at carbon, maybe only at energy. And these principles, engineering telling us what's all the potential there is in a given fuel, for example, all of this information is important, but it's not sufficient. And again, to reiterate my concern, if we're going to weigh these competing uses of forests, we really need to have all the information on the table. We've heard a little bit about the idea of co-benefits, and I've listed only a few here. We could easily list a half a dozen more. And again, I think we need to remember these are not just co-benefits, as like they're not only one more thing or set of things that we extract and use, which they are, but they're also the things that are part of the functioning of the ecosystem. And if we don't have all of these things functioning in the ecosystem, then we aren't going to sustain the productivity of the forest, whether it's to sequester more carbon or whether if it makes sense in situations to use it for bioenergy. For example, nutrient retention under accelerated harvest is one thing that we're looking at right now. So again, I'm going to use a case study, and I'm going to talk about Wisconsin, where we did this work using historical data. Someone that suggested that for any native New Yorkers that I had to show a map in case you might have a sort of a dim idea of really where Wisconsin is, this weird kind of reverse urban provincialism. Today we're right here, and Wisconsin is out here in the autonomous regions. So just a quick snapshot. We're going to talk about Wisconsin in the mid-1800s over a few decades because that's how late it was settled. And what the original vegetation and forests were like. And basically in the north, it was a hardwood conifer forest, and in the south, it was open oak, savanna with scattered prairie. So the settlement history is one of logging and the peak of land clearing by the early 1900s, and then recovery by the mid 20th century. The main data set we're going to use, I'm not going to talk about the 30s, is information recorded in the Public Land Survey. In other words, once we got west and south of Ohio, the federal government decided we need to be selling land more quickly, and we're going to just sort of square it up and really make it very simple. And in laying out the survey in townships and sections, they also recorded at every mile where they put a survey post, and every half mile, the tree species that were present, their size, and their distance and compass bearing from the post. And some of you may know something about spatial sampling methods, but you can actually use that information then with some caveats about bias and things like that to actually reconstruct what the forest was like. It doesn't work on small areas, obviously, the traditional forest stand. But for example, over the state, it's 500,000 trees. So it becomes a good sample to use for large areas. If we look again at the very general change from the mid-1800s, you can see that to the 2000s that the forest basically retreated north, and the savanna and prairie in the south was all converted to agriculture, and a portion across the mid-north part of the state was converted to agriculture. And then on the right is also a satellite image where you can see agricultural areas in light green and forests in dark. To get to the point of why we did this case study in terms of this meeting, and that is for forest carbon. And here we're only looking at above ground live. In other words, from this data set, we can only reconstruct live tree biomass. And here you see, here on the left, the pre-European settlement condition with a higher biomass here converted to carbon, where the warmer color is a higher amount of carbon. And in the 2000s, you see where we are in terms of recovery of that level of carbon and biomass in the forest now. So while we have these pictures were taken primarily in the 20s, for example, we certainly recovered a lot from that point. And because most of the landscape looks like the picture up on the top, the feeling is that, well, again, and this was how the eastern U.S. was described, is that, well, we're reforested now. You know, the ecosystem is back, and, you know, everything is fine, and it's not going to get much better. But to exaggerate only a little bit to make my point, much of our forests look like the slide on the left, and they originally looked more like the slide on the right. So they're not completely recovered. And if we just look at some general summaries in terms of, again, above ground live carbon statewide, the larger graph on the left in the early 1800s, and I just want you to pay attention to the magnitudes and directions here. That's what makes it, I think, more generalizable. You can see that while there has been a recovery, especially since the 1930s, that we're not where we were on the landscape or what we had on the landscape originally. And the story is a little more complicated if we separate the northern forested part of the state from what was prairie and savanna, because the relatively more equal level in the present and the south is really due to forest ingrowth with a cessation of fire following settlement. So now that we only have woodlots in the south, but instead of being savanna with scattered trees, they're forests because they've grown in because of the lack of fire. So in terms of above ground carbon, we have actually quite a bit in the south. So if we look at sequestration potential then, based on the numbers we've derived, well, obviously the big potential is in the north, and still very high potential on existing forest lands, even following 100 years or so of recovery. But then, not surprisingly, where you see the red colors is those lands that were both the most productive, highest biomass forests originally, but now have no trees. Obviously, those that have the most potential. And we didn't actually set out to actually make this point about agriculture, sort of to pick a fight, but sort of, well, that's where it is. And so, you know, that's kind of an interesting thing. Does have implications, obviously. And again, to look at, you know, where that is, you can see that band of agriculture where there's in the kind of the no matter how to describe it, the northern part of the southern half of the state that's somewhat forested, and then there's a band across the north central that is in fact agriculture, and that is where the highest productivity forests were. So if you're going to try to do agriculture in northern Wisconsin, which is not very easy, that would be the best place to do it. So people were smart. So again, looking at comparing the potential in current forest, that is historic minus current, and the airfoot of current land use, just so you can see again, there's relatively high potential in existing forest, but not everywhere. And again, the difference map, again, looking at the aerial photography of current land use. So if we try to summarize, well, where have we gotten from this, and what might it tell us? You can see in the blue bar was the original above ground carbon in the state, and then the present, where we see that the green forest regrowth recovery, but then the blue down below, that's a woody encroachment into savannas on the south. So that's in terms of above ground carbon. Below ground is much more complicated because it was prairie. That's kind of a bonus. And so those potentials then, if we just try to look at it in aggregate, the big red area of potential that is now in ag land, and then the potential on existing forest land that still remains in that kind of a purple color. So the trade-off discussion is that area up there. So the summary, well, total above ground live biomass is only about 60% of what it was originally. And what's interesting here in terms of forest is that's only 30 to 40% of the total ecosystem carbon. Remember, there's the dead and down woody debris, the snags, and especially the soil and below ground carbon is really where the big game is. And we're sort of in the process of trying to make some estimation of that, and there's actually several significant complications to do that in terms of land use history. In terms of northern forest, as you've seen, a big net loss in the north, and moderate to high potential in existing forests, very high potential in that band of northern dairy agriculture. And southern farms and woodlots, again, we've had this small gain because largely with settlement and cessation of fire. But there is still potential, in fact, in those southern woodlots. And of course, there's high potential with agriculture in the south, in the former prairie lands, but that is really the prime agriculture of the state. In terms of research, the overall need is, as I said, we're trying to look at other pools. But the broader implications, I think, is that to some degree, these results are relevant, if less in the West perhaps, but I think to some degree in all of Eastern North America, depending upon what the land use history was, what happened where and when. That the systems are similar enough and not, and often not primarily fire-driven. That's the other thing. They're more wind-driven systems. But this idea of high potential forest productivity in formerly forest ag lands, again, it was not a point we were looking to make at all. But then, if you think about the way things have changed, I mean, who knows in the future what the incentives might be and what might be on the table. And so this is something we should at least be aware of, I guess. Stranger things have happened. Again, this issue of carbon sequestration or bioenergy use, I think, really needs more work before we, charge ahead. We don't want to take forests, over the corn ethanol cliff, which our governor did in Wisconsin. Said we're going to be the Saudi Arabia of the Midwest. So the limitation is not biological limitation, but it's how we use the systems. That's the limitation, and that's the policy decision. And I can live with one I disagree with, as long as the stuff is out there being considered. I'm not a win-win kind of believer. The world is full, the landscape is full. We can change things, but there's going to be trade-offs. Let's just have them out there so we make the best decisions. Thank you. You think they can't remember the science-related questions? Or? No, I think nobody did. Go ahead. Here's a question.
I'm guessing now that the process of recovery of carbon in a depleted soil would be a sigmoid curve, so that it would initially rise significantly and then taper off towards some sort of an equilibrium. And
Yes.
you said we're now roughly in northern Wisconsin at the point of 60% recovery, you said.
Yes,
you said,
yes, yes.
roughly. So how do you project, or do you have a model that projects, or the experience that projects through
Yeah.
the variation of the landscape and the vegetation and the density of vegetation and the age of regenerative vegetation? How long might it take to approach 100%, that is the virgin condition?
Yes, well, I'm not able to project that, I don't think. For one thing, I think most of our model projections wouldn't come up with the same numbers that we found from the historical data. And so I think most of our models have probably been wrong. They're sort of parameterized on a very limited kind of data set, so I can't really project that. And I guess the other thing is that that's a caveat to all this, is that we'll never have what we had before, even if we set out to try to recreate it. We have to acknowledge that obviously land use history and what has happened, as well as the climate change, means that something different will always result. So I guess I'm saying no, I really couldn't hazard a guess as to exactly what the shape of the rest of this curve will be. What will the ceiling be? Yeah. I don't know what the ceiling will be. I think what we're seeing more and more now is that the ceiling will be higher than what we thought it was. So that's not, biologically, I don't think is the limitation.
One more question here.
The IPC is often quoted to assert that the assimilative capacity of the forest will reach a saturation point with temperature and higher levels of CO2. I assume as long as if you can plant new trees, that would not necessarily be the case, but that would be for old growth stuff, I would imagine. Do you have any comment on that? Your work doesn't seem to reflect that, what I've heard you say.
I think that that principle probably still holds, that there is that interaction between those two things, and then that will be the result. But I guess what we don't know is like the final shape of this curve of recovery. And what exactly the amount will be. I feel like we're less certain of that, but I think that evidence is showing that it's higher than we thought.
A lot higher, according to the buzz I've seen on his PNAS papers. There's a lot more there than we would have thought in storage.
Thank you very much, David. And as Jane is getting in position for her presentation, may I ask that you identify yourself and your affiliation before asking your question or offering your comment?
Oh, how do I get there?
Down at the bottom. Which one of the other two is?
Sorry.
Okay, here we go.
New version.
Yeah. Okay, well, thank you. And thanks to David for taking us back to the science, because the science, not only the science for the emissions analysis, but the science for as a basis for offsets is really, really important. And that's what I wanted to talk about, what the standards are in this area and how we get to them and where we need to get to. And I should say two caveats. One, I'm not going to add much to your information overload already. And second, I come from somewhat of a trade perspective, so I may add a little bit of perspective that you haven't heard today. Also, sometimes I think I have a little bit of hesitation in part of this area. I feel as though we're generating a huge market in financial instruments based on a commodity whose aspects are in some cases very ill-defined. And if that reminds you of derivatives or credit default swaps, then I'm sorry. But anyway, what's the context for sustainability criteria, MRV, and certification? Well, we've talked all day about the kinds of systems that we'll have to use, standards for offsets, for permit allocations, for set-asides. The voluntary markets, of course, use them. They're evaluating not just carbon, but also water. technologies. Offsets are going to be given for use of new technologies. So penetration of some kinds of new technologies are going to have to be studied and standardized, because they're not going to give offset credits for technologies once they're not new technologies. So that's something you might want to consider. So standards for MRV and voluntary markets are based on a lot of the things that we've talked about today. But you might want to consider that sustainability is going to probably be an increasingly important aspect of these standards, even if co-benefits aren't explicitly recognized. And also requirements in many of these systems may include third-party certification, and in some cases, for instance, embedded carbon in traded goods, also chain of custody and traceability for products. So this is a whole new world of standards, frankly. This is just a slide poached from the State of the Voluntary Carbon Markets done by Ecosystem Marketplace and New Carbon Finance, which I highly, highly recommend. It's on both of their websites, and I'll give you the link to it if you want, showing the growth in the voluntary carbon market and just in 2008. So this is obviously a market that's exploding beyond all expectation. And part of the reason, of course, is that the regulated markets haven't really kicked in yet, and the U.S. legislation is not done, and until it is, a lot of this market won't be subsumed in the regulated market. Anyway, what are the standards implications? Well, they're essential elements of compliance with almost all international agreements, such is the case with these agreements. They exist at multiple levels, public, private sector, many levels of complexity, many different agendas. Some companies and some traders are in this for pre-compliance purposes, and others are in it for PR purposes. So there are all kinds of agendas in this growing marketplace. There aren't any clearly endorsed international standards yet. There are a bunch of CDM methodologies in their database. Just to note that the WTO requires the use of international standards, pretty much, if they're not inappropriate or unavailable. And the WTO has kind of a problem with process-based standards. Product standards are okay, but process-based standards, if those standards are not related to the product, are kind of a problem in the WTO system. So this is just to note that the WTO still has the only binding dispute settlement process in the world, and unless the Copenhagen process comes up with something else, it's entirely possible that some of these issues might not be resolved in the right context. So standards are also determinants of price in the carbon market, and the less robust standards are, the less of a price the commodity is going to, the commodity based on them is going to capture. Agriculture products are now among the lowest priced products in the voluntary market. So, bio-sequestration standards development, I guess we've sort of covered the kinds of institutions that are generating standards. Nobody today yet has mentioned the ISO, the International Standards Organization, but I would just note that ISO standards are proprietary. If you want to use it, you pay for it. So this has implications for developing country use of ISO standards. Sustainability standards are becoming very, very common, not just in the food sector, but also for biofuels, and many of them are crop-specific. And, of course, in the forest area, there's been a battle for many years over sustainability standards. The Forest Stewardship Council was one of the first to launch a standard, and it was very quickly matched by standards from industry organizations. And then there are companies, NGOs, and traders who are busy creating their own standards. Walmart is only one entity that is generating a sustainability index, which will capture carbon values and energy intensity. And the World Resources Institute has done a lot of work here. The Chicago Climate Exchange, of course, has its own standards. And a lot of standards that aren't explicitly linked to the carbon or energy market area have implications for them. For instance, Global Gap, which is a global food quality assurance standard, has some implications here because it will place values and provide certifiers with little checklists on things like energy use and so forth. So nobody here has mentioned Canada much today either, and I won't cover this slide in detail, but I just thought it's notable that nobody has mentioned it because Canada is our largest trading partner, and certainly whatever standards we generate for our own program are going to be very, very relevant for Canada and also Mexico. I think it wouldn't hurt to expand our domestic horizons a little bit and take that into account. Canadian provinces have joined some of our state-generated schemes, so it's not perhaps a big problem. Whatever standards are generated are going to need to deal with the original conditions set forth in 2003 for LULUCF projects, and we've talked about a lot of those today too. Permanence, additionality. Originally, additionality, one of the meanings of additionality was that if the project was going to go forward anyway, if no carbon finance was necessary, then it wasn't additional. So that was a reason for sort of denying it additionality. Measurement and monitoring. A designated operational entity is needed to identify, to be identified and to use approved methods. And sustainable development. Originally, large-scale timber projects also were ineligible for CDM financing because there was no additionality there. They were thought to be eligible to, they didn't need carbon finance. So, but community, climate, community, and biodiversity standards, which are also referenced by the CDM, are also used now, and other standards like the ones I mentioned will probably be used in the future. And just a note that the CCB standards do not allow use of biotechnology because of biodiversity concerns. So I won't go over this this slide, except to note that the State of the Voluntary Carbon Market 2009 report reported that the top 4 standards now in use have basically consolidated in the voluntary market, and the voluntary carbon standard has the lion's share of the business right now. The gold standard, the Climate Action Reserve, and the American Carbon Registry are close behind. This list, by the way, I originally compiled just by going through the CDM methodologies database and pulling out references to standards that were referenced there. But the State of the Voluntary Carbon Market report has 2 pages of standards that are being used, so I didn't clearly find all of them. I suspect that even with a regulated market, many of the standards generated for use in the voluntary market will persist and perhaps even be referenced by the regulated market. And then just a couple of thoughts about market-oriented versus project-oriented standards. Both regulated and voluntary markets need performance standards. Project funding and development criteria are really important, but they don't go as far as standards go in terms of sort of generalizing the kind of behavior that needs to occur across projects and across regions and across countries. And bio-sequestration offers, of course, multiple markets. Project development offers the opportunity to stack some of these co-benefits into a project and to realize credits for all of them. But stacking may not be necessary in all cases, and it may not be possible in terms of market participation. We've heard people say today that carbon is carbon, and they don't want to necessarily include co-benefits in terms of a carbon market. So additionality, I think, will probably be a critical element, and performance standards can deliver it with good baselines, emission measurement methodologies, and technology and market penetration assessments. And then reconciling standards. Permanence obviously needs to be dealt with. The convention is to define it as carbon storage for 100 plus years, but obviously that standard will get significant derogation from standards, from practices and standards in the forest and agriculture sectors. Reversals, we've talked about impermanence, but we haven't really talked about the fact that permanence is also achievable in agriculture projects. For instance, destruction of methane in digesters is permanent. So it shouldn't always be assumed that permanence is going to be a problem for agriculture. It maybe not. We've talked about buffer stocks. We haven't talked much about differential valuation for less permanent credits, but that's a thought that's kicking around out there. And also, grading standards have been proposed for markets, depending on the robustness and the quality attributes of the credit. Also, price discount premiums and quantity discounts. So, back again to sustainability standards. Sustainability standards do, I think, embody a lot of permanence issues, because a lot of the attributes currently considered to be sustainability attributes may or may not be permanent. It's very practice-based. They're currently used as an adjunct to project criteria. Their advantage is that they can encompass multiple goals and address several areas. And of course, the standard systems are proliferating. However, my personal opinion is that there's really a lack of specificity in many of the standards. Sustainability standards are not generally metric. They're very practice-based. So it's difficult to account for benefits that are realized in a metric way. And they all include social and economic criteria. Some exclude new technologies. And a lot of them require full traceability and chain of custody certification. That's very difficult for bulk commodities. Not impossible, but very difficult. So the conclusion, I think, that I'd like you to take away is that more transparency in standards development would really be desirable. And I have yet to see a real database of what's in all of the standards listed in the State of the Voluntary Carbon Markets, and I think that would be really useful. It's hard for companies and potential market entrants to find their way through the maze of these standards, and transparency would really be valuable here. And then finally, I personally think the role of third-party certification needs to be clarified. In terms of monitoring and verification, it may not be the best way, or ways to do it need to be explored. There's been some discussion of GIS models, for instance, to measure soil organic matter, and obviously it's too important. It's too difficult to put carbon flux towers in every agricultural context. So something needs to happen there. But many developing countries find that third-party certification of other kinds of projects is expensive, and very, very expensive and very time-consuming. So perhaps some variation on that kind of certification needs to be explored. And then finally, just one thought: as regulatory systems do come into play, right now I think there's sort of a race to the top going on among the standard systems. They're all trying to prove they're robust, they can be used. Maybe Pennsylvania will become the model for the federal system. But as soon as a regulatory system does come into play, then there are kind of different incentives. And having worked in other regulatory systems, I fear that sometimes that means a race to the bottom. So it's worth keeping an eye on standards and their developments. Thank you.
Thank you very much, Jane. Rick, we've heard a discussion of the science and the modeling. We've heard a call for harmonization of standards. Farmers are a key part of the whole question. Happy to see you here, even though it's at the end of the day.
Thank you, Joyce, and good afternoon, everybody. I don't have a PowerPoint today, and it turns out to be a very good thing, because after listening to all these excellent presentations during the day, I've changed my tone and aspect of how I'm going to present about 3 times. So actually turned out to be a good thing. I think I'm the only one on the panel that does represent some of the landowners that are going to be actually involved in implementing the things that we've been talking about today. So I want to present that perspective to you all, and where American Farm Bureau Federation fits and what their positions are on all these issues. First of all, I want to kind of crystallize why agriculture and forestry are important in any climate policy. And we've heard around that, we've touched around that today. EPA estimates, based on their inventory of carbon emissions and sinks, that agriculture and forestry emit about somewhere between 6 to 7% of all total greenhouse gas emissions in the United States. Now, for agriculture, we're really talking about emissions of methane and nitrous oxide as opposed to carbon dioxide. So what we're talking about when we talk about emissions and sequestration, we're talking about carbon equivalents. I just want to make that clear. That same EPA document indicates that agriculture and forestry, and mostly forestry, has the potential to sequester about 15 to 20% of total U.S. emissions. The USDA right now says that agriculture and forestry, again, probably mostly forestry, sequesters about 11% of all emissions. So we have 6 to 7% on one hand of emissions. We have 11% now sequestered, 15 to 20% possibilities. So from a climate perspective, it makes a lot more sense if you're really interested, if the focus is to reduce greenhouse gases in the atmosphere, it makes more sense to try to concentrate on incentivizing that 15 to 20% that you can sequester, as opposed to trying to squeeze a little bit out of that 6 to 7% of emissions that we have. And that gets to some of the regulatory issues that Chris briefly touched upon with EPA and their greenhouse gas regulations that are coming down the road. It may be a situation where they will, where they can achieve reductions in some respects, but for agriculture, it just doesn't make sense. Actually, they might wind up increasing emissions in the long term. Yes?
Excuse me. Sorry. Can you identify yourself for the rest of us?
Turn on your mic.
Daniel Hillel. Just point of clarification. Is the 11% that are now sequestered part of the 20% potential sequestration?
Yes.
So
it's 11.
The net is 20 minus 11.
That's correct.
That is still possible.
Yes.
Thank you.
That's my understanding anyway. Agriculture and forestry offsets are important in this role, as we've talked about today. We talked that they reduce the cost of compliance, but what we really haven't focused on at all is the fact that those costs of compliance that are going to be assumed by the capped sectors, those costs get passed on to consumers, farmers, ranchers, homeowners, and the like. So the fact that reducing those costs to capped sectors also reduces costs to consumers and makes the program a lot more affordable. And I'm also glad to hear people talk about the co-benefits and the fact that this is a very important factor. This, we think that agriculture and forestry are a particular advantage in terms of providing offsets. And I want to commend the USDA. They have established an Office of Ecosystem Services and Markets within the department that is trying to build a system to incorporate all of the different kind of environmental co-benefits that agriculture can provide. Now, from a legislative front, agriculture, we believe that there needs to be a very robust offset provision for agriculture and forestry, and that means all of the practices that agriculture and forestry can provide. We also believe that legislation ought to specify an initial list of those offset types that will be qualified to provide offsets once a program comes into place. This is important for investors seeking to invest. They need to know what they can invest in. It also gives them a head start in developing these projects so that when 2012 or whenever the effective date of this legislation is, that these offsets can be in the pipeline and ready to go right at the beginning when they're needed. Waxman Markey does a good job in providing that. Kerry Boxer doesn't. As Chris mentioned, it provides that the President shall consider which type of offsets to include in an initial list. What this does is basically sets the offsets program back at least a year and probably more. So it will be important to have that type of provision clarified in the bill. It was mentioned permanent conservation easements in terms of providing protections for forests. That's not going to fly with our members. Permanent conservation easements are not something that is favored by farmers and ranchers. As was mentioned here before, it really doesn't do anything to protect carbon sequestration because of the possibility of unintended reversals such as wildfires and insect devastation and that type of thing. So I would discourage anybody from doing that. Farmers and ranchers do want to do the right thing. They will participate in greenhouse gas reduction activities if a bill passes. We talked a little bit about farmers and ranchers planting trees, taking cropland out of production and putting it to forest. If it's economically feasible and if it economically makes sense, we're not going to tell our people not to do that. Our philosophy is that people ought to be able to make the best use of their land that they can. But policymakers have to consider this point, the fact that if agricultural lands are taken out of production and changed to other uses, that is going to reduce food production in the United States. And what that means, and because the United States is such a huge supplier of food for the world, this is going to mean higher costs for food, and it's going to increase world food prices. Just something to think about as we move forward. Again, I say we're not going to say anything about that for our producers, but that is something for policymakers to think about. Now, we heard about the question of EPA versus USDA. Who should administer the offsets program? We strongly think that at least for the agricultural offsets title, or the agricultural and forestry offsets, that it should be USDA, and for a number of reasons. We do think that USDA has a better relationship with farmers and ranchers. They have the infrastructure with the FSA offices locally, the NRCS offices locally, and they have the infrastructures to administer it. And USDA has also done a lot of work already in the area of looking at monitoring standards, measurement standards, and verification. They've done a lot of work with that, and they're well equipped to do that. It's important because whoever makes the rules makes a big difference in terms of how they're administered. Now, getting to monitoring, measuring, and verification, which is the subject of this panel, we fully support the efforts to develop standards that are workable and that are important, because we do believe that it's very important to have offsets integrity and offsets, at least on the sequestration side. We do believe that we do need to make some adjustments in terms of permanence and additionality. Permanence, as we've heard, is not forever. Permanence, unintended reversals and things like that. There are ways that we can get around that, as we've heard today, buffer, reserves, and insurance, and we think that those are acceptable ways to address that issue. Additionality is another issue, especially with sequestration. Now, when we talk about that issue with our farmers, some of these people ask me the question, okay, what happens? I've been no-tilling for 10 years, and does that mean I can plow up my fields now, and then when this program comes into play, I can readopt no-till and become eligible to participate in this program? I tell them, we don't want that. We don't want that to happen. So if we can have a program that recognizes certain early actors, people that may have been doing these practices for a few years, not 20 years, but maybe 8 or 9 or 10 years. 2001 is the date we've picked out. If we can allow those people to participate and they still have carbon that they can sequester, we're not asking that these people be paid for past sequestration, what they've done in the past, but only what they have carrying forward. This will prevent people from plowing up lands in order to re-enter the program, and that we think has more environmental damage than it does benefit. So with that, I'll end. There's a lot of other things I can say, but I want to leave a little bit of time for questions. Thank you very much.
Thank you, Rick. And before we get to move on to that other final seminar, that would probably be a drink for most of us in the room. Are there any questions?
My name is Maria Filipovic. I graduated at Master in Public Administration at SIPA on the program Environmental Science and Policy. I have a question about raising food price. If your business practices would be such that you actually save money while producing food, why do you think that following standards would increase price?
I think that the issue becomes, it's a question of supply and demand at this point. The supply of food would be reduced, and the demand for food would not be reduced. So it's a question. Less supply means and equal demand means higher prices. That's really what we're talking about. It's not a question of business practices at this point.
If I can just add on to that, one of the things that needs to be recognized is that modalities are very important. And I think at the outset, I pointed out that U.S. some demarcation or juxtaposition between the U.S. and the rest of the world on this just is not going to make for a robust market for U.S. farmers or for farmers beyond our shores. And so the challenge here on whether or not it plays out to higher food prices is how we do it. Some of the points that Rick has raised presents, there are other scenarios under which supply is not dampened. Where the supply comes from is dampened. And what I think becomes very important is whatever the modalities are, recognize that producers are consumers, and so let's work on the technologies and have those that are ready for when the legislation becomes effective.
Okay, yeah, the question was, I presented the perspective from American Farm Bureau Federation, and that there are other agricultural organizations such as National Farmers Union and others, and the question was whether the interests that I had mentioned today are consistent with what they've said. And that's a very good question and raises a very good point. We have been working with Farmers Union and a whole host of other agricultural organizations, at least on the offsets issue. We all agree on the issues and the points that I made with regards to offsets and the need for them, the early actors, additionality, permanence, and that whole thing. Where our organizations differ to some degree is in an overall perspective on potential legislation. There are a number of factors that our organization has considered with regard to the overall bills that are different than the overall perspectives from these other organizations. And that's why we get different positions on the bill. But at least on the issues that we talked about today, we're all very much in agreement.
Well, I think we'll wrap up things for the day there. Just a quick word of thanks to all the panel moderators who pulled all this together. A special word of thanks to all the speakers who came, all the folks who were able to attend. Fascinating day. Lots of technical issues, still some major policy issue to be worked out. May I just conclude with a question, and that is, at a high level of generality, to what extent are things pulling in the same direction, and what are the implications of that for the policy issues and for addressing some of the scientific issues surrounding biosequestration and climate change? So again, thanks for everyone's attention, thoughts, help, assistance, and time. And a round of applause for the final panel.